topic visualization. So, in stat or any data analysis field, visualization is most important, right? So here we will discuss about how to make a graph. So basically you will say, sir, we can show our data result with the help of visualization. So visualization can be like a graphs or like a chart. So basically charts and graphs are almost the same, but we will see how we will make it. So here I want to discuss on histogram. Okay, the box plot, error bar chart, and bar chart with the different independent variable. One, if I will have a one variable, you will see you can make. If I have a two variables, I can make. Okay, so this is important. So bar chart can be if I have a data which is repeated type of a measurement. Okay, so we will also discuss. And scattered plot is also there. So these are the basic one which I will discuss here, and apart from it there are many, but we will see when we have some when we will apply some statistical technique next sessions, maybe some chart which are very different, but it based on some technique, right? It is based on the method which we are applying and how we can show it. It is important, like a script plot, QQ plot we have, but it will come when we will apply some methods, right? So please try to understand. This is the basic one, which is important. Okay, and based on the other chart, we will do later on when we will have some techniques, and you will say, yes, this chart we can make, but not now. So is it clear to everyone? So we will going to focus on this type of a graph or visualization. Okay, let's start our day. And first of all, I would like to talk about the graphs in SPSS. You will say, sir, how we can build? Obviously, there are several ways. Okay, so let's see. I want to show you. You can go. Suppose I already loaded the data. Do you know last week we have same data and we did some practices. So it depends upon the data against. If you want to make a chart, you should know if this data is suitable for my chart or not, which is important, right? It should be suitable. If your data is not, because every chart has some rules and restriction. Okay, so I'm not going to talking about in detail, but I will show you some practices, and you in the end of the lesson you should know, if I have this data, I have to make this chart, right? So where I can make a chart here, do you know which option I have to select? Can you see some data here, option here, graph? Can you see? So I can click on the chart builder. This is the first method. Second method, you can use graph board template chooser, right? So you can also use that one. Okay, so first method you can use, second method use, and third method is also available, legacy. Legacy is there, mean to say there are a rich library, rich options of our chart builder. So here have a look: bar, 3D, line, area, pie, high-low, box plot, error bar, population pyramid, we have scattered plot, we have histogram. So these are the most important, mostly used basically. So it is your choice, what you want to use and how you will use. Okay, and okay, so if you will mostly I use, like here we have to click on the chart builder, and let's see what we can have. Okay, so let's see. Okay, please be ready with this data. So have a look. We can have this type of a box. We will use different chart. Can you see left bar here, which is the show different type of a chart, right? Suppose bar chart. So bar chart can have simple, cluster, stack, 3D. If you want to make a 3D, obviously you can make another variant it has. Okay, and this is a error bar, simple error bar, and cluster error bar plot. And in the end you will know what is the error bar and cluster error, you can make later on easily. And it has some properties, chart appearance, you can make any color as you want, right? So you can make frame, outer, inner, grid lines, XY as you want, you can do it. It is your choice, but it will take some time. Okay, but you can do. Okay, it asks the practices. Okay, so this is the way you can use it. So where you have to click on the graph and chart builder. Okay, so this is important. Okay, some charts are very related. Okay, so let's see. This is clear. I think we can make how to use it. I put some snapshot for your help. Okay, you can check it. Okay, first of all, histogram. So what is this histogram? It is very important. Basically, when our data like a continuous type of a value, continuous mean to say like numeric value, right? So if you remember last time we discussed about the data. So I discussed about we have the data like a nominal data or maybe the scale data, right? So I want to show you once again here. So can you see this is a nominal data and scale data? That's all. Nominal data can be categorical. Last time we discussed scale data is always the numeric value, right? Which are the some digits. So is it clear to you? Now please try to understand this histogram. Remember, we need always it will be make with the help of scale type of a variable or scale type of a value, right? With one scale variable. In this example, I took the example of one scale variable, right? So x-axis and midterm marks. So here in this example, I want to show you. I made a histogram. Okay. Here is the way you can check simple histogram of marks midterm 2. You can select any test. So I selected in this example second test and first test. I wanted to check what is the frequency actually over the left curve y-axis, right? Here on the y-axis, I selected the frequency. What is the actual frequency there in terms of percentage? So how much students are separated over this line, right? So x-axis midterm marks here, this one, and y-axis will be the frequency in terms of frequency, right? So what it will tell me, what it should tell me. Do you remember my last lesson? So we discussed about the term normality, right? Or data is a normal or not, right? How I can check the normality? We have some test and perfect graphically curve. We need to use it. For that, we need a very good curve, that is a histogram. Histogram always tell us my data is normal or not. Obviously, I know if my data is a complete normal data, the histogram should be accurate, like a bell type of a shape. If you remember last time, I show you, I think I already opened that file. Can you see this type of, it is a complete bell type of a shape. So in that case, it can be the exact normal data, right? So I think we discussed last time. Now also it will tell me the shape of distribution. Like, so what is the actual shape can be distribution of my data? In this example, we have very small records, but in real life we will have thousands of million of records. In that case, we have to learn about this histogram. Okay, so it will tell me what is the skewness, right? What is the courtesies of my data? So what are, how much spreading the data or variations in my marks here in my data here? Can you see this is a very less separate data here, and this is a highly separated data. So if I talk about in this example, it is not highly separated one. Like, can you see it is just like in the center middle of the data? So this will tell me the skewness and kurtosis. So let's go back to skewness and kurtosis. Okay, so I think I want to show you once again that one is right. So that is the positive skew data, right? So whenever the tail will be on the positive side, that is perfectly positive skew data. Whenever your tail of data should be on the left side, mean to say negative side, it should be negatively skewed data. This is the general formula, right? Wherever your tail is bending, that is the name of the skew distribution, right? So it is important. Okay, now let's see. Uh, I in front of you, you can see I made a two curve. right? First, this is a exam second marks, this is exam first marks. Please let me know what is the skewness of the second bar, or maybe the first red one bar. Please, anyone. Where is the, you can see the tail is bending, right side or left side? So the thing is, wherever our tail should be bending, can you see the tail is be on the left side? Basically, there is no rush or load on the left side, right? So it is going towards the left side, right? It mean to say it must be the negative skewed data, right? So this is a good example. Please try to understand. This can be the negative. So yes, it is like a negative skew data. This is highly separated. This is highly separated. It is less separated, but both looking like a negative skew data. Okay. So this is I can have an idea from the shape. That's all. So did you get the idea? This is a skewness. Now we can also check the curtices. Do you remember the curtices? Let's see back. So that's why it is important. Curtices, right? Can you see this is the exact normal distribution, or three are the perfect normal? So can you see this is a flat type of a curve? The third one, right one, this is a flat. So I think there have been some names. Do you remember? Leptokurtic, mesokurtic, and platykurtic. So if it is a mesokurtic, it is a perfect normal. I think this one is intermediate. If my data is like a flat, I should say this is like a platy type of a curves, platykurtic, the blue one. So let's see my data here. It is like a, what type of a curve it has? Like a platykurtic, right? So can you see what curtices it has? Platykurtic. Okay. So if I talk about uh, this one, in this example here, what is this one? What is which type of curtices you can have idea? It is looking like a leptocurtive, right? Which curve? Leptocurtive. Okay, so it was our previous lesson, but in this lesson, please have a look with one scale variable we can do, right? So how you can make it? Okay, let's go to there and go to the data. You can check first or second, whatever you want to do. So click on the graph. Please do with me now and click on the chart builder. And what we will do here, can you see this box, dialog box will be there? Where is the histogram? I think here you can have a different type of histogram. You can choose. This is very simple. This is a stack. This is the frequency polygon type histogram, population pyramid. It depends. So let's start from here. I think the basic one we can use. You can double click on it. You can drag and drop. It is very easy. So it will make you a small board. This is a board. You can use some data over here. Just you have to drag and drop facility here. Okay. Okay. So I told you we have to use uh, the scale data only, right here. Can you see? So x-axis should have a our numeric value. So you can take an example in that case. So suppose uh, I want to measure the second test exam, I can put on the x-axis, right? And here in the right side, you can do anything you want. Histogram, you can put the count. You can also take a count value, cumulative count, percentage, cumulative percentage value, and mean as well as you can use. There are a lot of statics. So basically, mostly we use the percentage. Okay, so it will tell me the percentage basically, which will on immediately on the your left curve, mean to say y-axis, right? So here you can see the bar as you want to do. Okay, now so suppose you want to change any color, so you can use any color here as you want. It can be for red, it can be for right, as you want. Okay, so let's see. I think it is done. I want to show you once more. So you have to click on the OK. Can you see the graph is running? Okay, so let's see. It will be making a file for me. Which file? Output file. So because my system is very slow right now, that's why it is taking some time. So let's see which file is making for me. Immediately it will create a another output file. Let's see what will be the output, right? Can you see? This type of a histogram is in front of me. So please have a look. This data obviously in between up to 3 to around 11 or 10, right? So I think the value lies in between this portion. So this is like a spreadness, right? So again here mean should be 0 and standard deviation should be high, 1. Standard deviation is perfect, but mean is very high, but it doesn't matter that. But if we have a exact normal data, so basically the rule is 0 to 1, right? But as we have a very few samples, so in that case it is not a good idea to go for 0 to 1. So just we can focus on these curve, right? So now, can I edit more in this data in the graph? Yes. The thing is, you can use like a copy. You can use a copy as an image and send to anywhere as you want. Okay. If you want to copy as a like a MS Word or MS Excel file, then you can use only copy data where you can easily edit. Okay. But here, if you want to edit here in the SPSS, just double click, on this graph. Immediately it will open a chart editor for you. Every graph will use chart editor. You can use anything you want. So suppose you want to uh, change the title, you can click on it and do whatever you want to do, right? So left x y title you can use, x bar this is a title, x bar title you can change, and also you can change everything you want. Okay, now I want to put a curve. So lot of options here, please read it so you can have our internet and find what is that one, right? So you can also change the coordinate system here, like in that case. Okay, it can be on the transpose. We said this is a transpose. Okay, so if you don't want to use, do it undo from here, right? Okay, now I want to check what is the curve it should be make. Can you see here? Normal curve. Yes. Yes, it is looking like a normal. This data is looking like a normal. Okay, but please don't use this graph for analysis, because yes, in graph it is good, but you have to apply some test, which we have last recording. Please listen the last session where I applied some test. Please also give the reference of that test. Okay, that value should be is greater than 0.05 for Shapiro-Wilk test and KS test. Do you remember last session? Also give a reference for that test. Value should be there. Okay, don't rely on this type of a graph, but graph can give you the hint or idea. Okay, so it seems, sir, it is like a normal, right? It is like a normal, but it is like a little bit negative skew data, and exact value you can check using the some test. Okay, so you know very well how to do it. Okay, now how I can print it over some values over here. So please let me export. Click on the export. Export where you will export any folder. Suppose here you want to do type, you can use PNG or anything you want to do, right? So it is important. Okay, so you can easily send, it can be there. Suppose error bar is a folder, you can save there. Okay, as you want, it is your choice. But mostly if you are working here directly, you can use a copy image or a copy here, it is also a good idea. Okay, so now you are able, the histogram is clear to everyone. Here please have a look. I can make it two different type of a histogram. Please try to make a histogram for other data. You can make for the final, you can make for the midterm 5 4 6 anyone. So this is the only example, but you will have a different type of a data in your different type of a data in your real life. But remember, value we need only this type of a value, right? Numeric value we need it. Mostly we work for the continuous type of a value. So is it clear to everyone? Can I go next? Are you done with it? Okay, now next go with the box plot. Okay, what is the box plot? Please try to understand. I put some pictures over here. Try to understand first the box plot. Box plots are made of box and whisker. Can you see? These are the whiskers. This is the box, right? It made up of a box. This is a box and two whisker, one and two. This whisker will tell me the basically range of data, right? From where my data start and from where is my data ending type of, right? So this is the way you should know this is a whisker. That's why we say whisker plot as well as sometime. So in short, we say box plot. So box plot, which tell me only median. Can you see median? Upper quartile here, lower quartile here. Three things we need to know here. I think in first or second lecture I discussed it. So upper and lower quartile, limit within a which middle percentage of score. In this example, middle, in this example only, middle is 50% data. Median is a 50%. That is the middle here, that portion. At top 25% here, which is near to the upper quartile, and lesser 25% is the lower quartile. This is standardized method and to understand the way. So whisker show me the range of score actually, where my scores are living. So suppose example here, I want to show you here example. So can you see here? This is suppose midterm. What is the maximum value? Minimum value is maybe 0 or 1 score, and maximum can be 10. Okay, so if my all students are brilliant, if the paper is very easy, if the exam is easy, all do you know all students can have the good marks, maybe above 7, right? So in that case, what should be the range? 7 to 10, right? If the paper is very difficult, all students are getting a very low marks, maybe up to 6 or 7. So what is the range? From 1 to 7. So we will see what is the exact median, right? So this is the way to understand the concept of the box plot. Okay, so let's see. I made the box plot over here, simple box plot of marks, midterm marks. Here, can you see? Remember what data we need for it. It is important. So I wrote here, I need one categorical data, and second, I need one scale data. So right, so I need that one. I want to check what about our gender distribution, gender median of the marks, like a box plot. Okay, so we can do it. Let's see for our data here. So graph chart builder, please go for it. Okay, so where is the box plot? I think here, right? So before going to it, doing reset, do reset, everything will be finished, and click on the box plot. There are a lot of box plot, but we mostly use a simple box plot here. You can make a practices later on a different type of a box plot or something, but please have a look. Can you see this is the dashboard? Okay, I can use again. So let's see, in this example, I took, I think, the first term exam. Okay, I want to check what about the first term exam, right? So this is the first term exam. It should be on the y-axis, and categorical or nominal can be here. I think this is a gender, male or, can you see this is the description here? So I can put on the x-axis. So can you see female or male, right? So you can change the color as you want. It is your choice how to change the color. You can do it. Okay, so you can change the color individually later on in editor. Okay, suppose female can be red or male can be blue. It is your choice. Okay, let's see what it will give me. If I will click on it, immediately the same file where I made the histogram, it will be going into that file. No, obviously you can make a separate file, but if it is open first, you can do it. Can you see my box plot is created here? Okay, so try to understand, in this box plot what you can observe. Again you will say, sir, here there is a median over here, and here it is a median over here. So in this data it is showing the, but basically if you will say all the students, if I will say from as a student, I can understand the box is starting the, you know, this color is showing the actual marks of the range starting and where it is ending. It is starting from here, somewhere here, for female, and for male it is starting from here, right, and ending up to 10. So I think little bit female students are a little bit more, okay, so mostly here. So basically female students are looking very intelligent, they have a good marks, right, because their marks starting from actually from here, right. But for male their marks starting from maybe 50%, 55 or 55% or 5 here and up to here. So that's the meaning of the box plot. Female marks starts near the 6 here, okay, and maximum value goes up to the 10. Majority of the males have more than 7. Can you see here? Majority of, can you see this, that line, that bar? Okay, so majority of the students male more than 7 here, and the lower portion will telling me the students who have a very less mark, as because this is the median over here. So majority of students have that one, right? So similarly, majority of female have more than 8 marks. So can you see 50% ratio is okay with the female. So almost 50-50 they are okay. But here majority of students are of male, they have very good marks over here. But starting range is here. So please try to understand, this is the way to identify the box plot. So I would say values are dispersed more as compared to the male. So conclusion is male students has a very less dispersed, and female students are data is more dispersed here. So this is the way, right, to understand the box plot. Okay, you can change in a editor as you want, it is your choice. Double click on it, change the color as you want, you can do it. One more thing, can you see something is left side, what is this 70? Please let me know what is this 70? Anybody knows about 70? So in my
Please,
data set, this record, this is a record number. This is the row number. Let's go to the row number. What is that? 70. Okay, let's go. I want to show you
can you
here.
see the series?
Let's go to 70 number. 70. Okay, can you see the 70 here? This is a Deepa. She is a female, minority group, third year. Oh, can you see this value? 0. She scored 0 marks in first exam. Other exam she's again a lower somewhere, right? Please just try to think, this is a 0 only, that's why I think it is an outlier. Now next is the error bar. Okay, error bar, I would like to also show you, because there is a bar, there are two type of a bar, remember, in a data analysis. One can be the simple bar, second can be the error bar. I will discuss two together, but simple bar you know very well. Okay, it is very simple, but we have to think about the error bar actually. Okay, let's see actually. So here it will have one nominal variable, it can be categorical, and one scale variable. Okay, please remember, this is a condition, nominal variable can be here. Okay, so you can use a more nominal variable like female or male, other can be here more, but in this example only that one. But remember, there cannot be a only a nominal variable, there cannot be a scale variable, only scale variable. Okay, we need a combination, we need a combination of both, that's all. Okay, so example, histogram, do you remember histogram? Is there any nominal? No, only scale can be a good idea. Okay, so same in box plot, we need the combination. Okay, so let's go for the error bar once again. So what is this error bar? Error bar basically tell me the mean score. Left side, the y axis always show the mean score. I want to check what is the average of female student, right? What is the average of average marks of the male students? So error bar sticks out from the bar like a whisker, right? Can you see the upper bound and lower bound? It is a whisker, right? Please try to think a difference between box plot. Box plot were basically for taking me telling me the median, and range it was just for the interval only. But here I cannot have like interval. It will tell me the exact confidence level, that is the 95% confidence level. 95% mean to say, with the help of error bar, I can prove that 95% of the student can have this type of a passing marks, right? So which was not available in the box plot. In error bar can tell me that precision value. Okay, standard deviation, it should tell standard error of the mean. So can you see the last one is 95% CI. CI mean to say confidence interval, or sometimes we say confidence level. It doesn't matter. Okay, so the same thing. Okay, error bar here. Can you see the error bar over here? I made already some error bar to understand the example. So here, let's see for the final exam. I think I made the final exam. Okay, let's go to our graph. Please do practice with me. Chart builder. We have to see the bar. Where is the bar? Can you see the bar? It is the bar. So these are the simple bar. I will talk about later on. I think it is okay. But here, can you see this type of a clustered error bar? This is a simple error bar. So let's, before starting it, reset it and click on it. Now, what I will do, I have to take the gender on the x-axis. I didn't mention here. It is understood. So it is on the x-axis, and y-axis should be the final marks. So what is the gender over here? Okay. And what is the final marks here, right? So can you see it is showing me the mean value? Automatically it will create a mean value. Beside of the mean value, you can use a lot of things: median, group median, mode, minimum, maximum. It is your choice, but mostly we show or use the mean value for data analysis purpose. You can use another metric, your choice. Okay, so please try with your practices later on, but mostly we use the mean. Okay, so you can change any color or something. So I don't want to go into, just focus on the topic. So let's see how it can create a box plot for me. Let's see. Can you see? It is created a box plot for the gender, right? So it is above 60 for the female. Again, I can have an idea. The students, female students, have a very good marks. They are looking very intelligent as compared to the male here. Can you see here? So it will also like using the some whisker type of a box plot showing the lower range and upper range. But basically it will tell me the average here, mean over here, y-axis. So average of students, 95% females. The mean value of the 95% female should be around 60, 64. Can you see this dot? I think it is near to the 64 or 62 somewhere. Can you see here, right? 64, 62, sorry. Can you see 62? This is the exact mean value, right? In the female. And what about the male? What should be the exact mean value should be, which is confident by statistics? 61% around, right? Can you see the 61% value is here? Okay. So how you can print this value here? If you want to print a value, you can use editor again and print the value easily. It is your choice. So what I did here, basically for you, I use a copy and I paste over here that chart. Now you can check the value easily, right? Okay, so now female marks means very high looking. Male means male mean, that is the average. Mean is the average. Mean average score less, right? I can have an idea only in the final exam. Now 95% mean should above 60%, and for female it should be around, in this example, around 50. Can you see what is the lower range here? Around 58, right? Up to 63 somewhere. This is the range. So the conclusion is 95% average should be above 60% for the females, and 58 to 63% should be. So this is the exact value. This is the confidence interval. So error bar is a highly powerful graph which can tell me with the some confidence into 95%, mean to say 95% is true. Okay, so next is, I think this graph is again for the final marks. So what about the final marks? In final marks, 95% mean should be range around both for male and female 7 to 8. So it mean to say mean should be the same. It mean to say in final exam, it seems boys and girls did very hard work and they are looking very equal thing. So this is the way. So both are seems very nearby. They are very near. Can you see the points are near here, up and down? This is the way. Now simple bar is, I think, not hidden from you. It is very easy and to be applicable, I'm sure. Okay, have a look how I can make a simple bar. Very simple. The left, the y-axis should have a average value of the final marks, and our x-axis should be the male. Okay, very simple. And here I make for different for section. I think this is for the section. Okay, in which section there is a exam marks average. What are the major average marks in the sections wise? I want to see by the section wise. I can check it. I want to see by the male wise. I want to see by the caste wise. It is my choice. In this example, I show you the gender, and here the section wise. So section 1 has high marks with average of 64, right? So and others average is very less. So I can see, I can have an idea. Section 1 is very intelligent student with the group A is with the intelligent students, seems, right? And very less average I can see for the section number 3, group number 3, right? So you can easily make that bar chart. Okay, and how you can make it? Very fast. Go for the graph, click on again the reset. Please first do reset and again bar. Can you see these are the different type of a small bar? You can use simple bar. Okay, and obviously you can use for a suppose section you can take here. Okay, now I'm taking a different example, and okay, final marks or first, you can choose any. So I'm choosing the final marks here. Okay, it will take the mean value. Don't worry, you can have different matrices, minimum, maximum. You can also try. Okay, it will give you the different graph. Okay, so basically we use the mean. What is the average? Okay, so let's see what should be the output again. I am using the same file. Let's see. Can you see? It seems section 1 is looking okay, intelligent, and section 2 is very less. Section 3 is very less. It can, you can have the idea now. And how you can put labels over here, I told you in the starting. Go editor and put some value. Okay, so it is the combination of a simple bar and a box plot. Please think, right? So box plot I show you previously, but here it is the combination of like a whisker and bars. So error bar, please use it, 95% confidence, and it will tell the some statistics here. Okay, so let's go to the next topic. Bar is clear to you, I think. Here, can you see the gender? I also made for a gender. Please see, almost it is looking like equal, right? But actually it is not equal. Female has a high marks, around 62%, 62 mean, right? And male has a 60, right? Again, it is proving here. Okay, let's see. Cluster bar. Okay, so till now we discuss about the bar. We have a good facility about a cluster bar. So when we have to use a cluster bar, when practically when I want to use on the y-axis different matrices, mean to say different scale variable. If I will have a more than one scale variable, in that case I can use uh, the cluster bar, right? So in that case, with two nominal variable and one scale variable, in this example I used only one scale variable and two nominal variable here. On the right, in the x-axis I used two different type of a category, right? So and female, okay, let's see how we can make it. Cluster bar, first of all I think we should go for graph here, chart builder. Basically it will be like a group. Cluster mean to say group. To reset, okay, so again is a bar here. Let's see where is the cluster bar. I think it should be, yes, okay, this is type of cluster bar. It is also important you can use, and when we have to use we will see. Okay, put the in this case I want to check about the two different category. Okay, I want to check by the gender and with the help of section. So take a gender on a cluster side. Okay, and in this example I'm going to take section 1 2 3. Okay, section 1 2 3, right? So I put two nominal variable over here. Okay, and what about the count? I want to show you here. Let's for the final marks again. I think better to see the final marks. Again, obviously it will give me the mean value, right? So you can change the color as you want here. You have to check that one, and you can change the color as you want, like that. Which color you want, please use for your analysis. Okay, okay, I think it is good. Let's see. Okay, it will create a something for me. Now I can have it, I can measure with two different variable, with the point of view two different variable, I think. Let's see what is your gender. So now I can see female students in a section 1 is looks very not very little bit lower as compared to male. It is showing from here. In section 2 female students looking high, good students, right? Brilliant seems. In section 3 perfect, they are highly intelligent looking as compared to male. Only this example, right? So can you see what is your gender? I can use it here. In which section do you study? So x-axis is showing me that the section number, the y-axis for my marks, and the label, basically the color. Okay, the bins like working for me like as a gender, right? That is male or female. See how I can group. That is the meaning of the cluster bar. Okay, let's see for the another example. I think here I took for the gender. You want to check for the gender as well as. Okay, sorry, gender we did it now, and I want to check the section on the right side, and okay, it's a good idea. Okay, chart builder. What I will do now, I'm going to use again reset and bar. Okay, and now I want to take a genders on the x-axis and final marks, or maybe you can take the first exam. Just I'm not taking the final marks, I'm taking the first test marks. And if you want to check about the section here, okay, section can be on my cluster side. I can make a cluster. Let's see what is the output. Now I'm looking for a gender wise here, right? So basically here I can see based on the x-axis section wise, based on the x-axis gender wise. So what about the gender? Can you see which students are looking uh, like a like a plot like a male? Can you see from section 1 to section 3 the male students are going downside here. In section 1 looking very good students, boy students are very intelligent. Section 2 very less, section 3 very less. They scored marks. Similarly, in female, we talk about the female. Females are almost equal. There is no downfall I can see. So I can see section 1 with a very good female student. They scored in a first exam, right? Section 3 is the second topper. Section 2 is a middle level. Okay, so so you can use, if you want to check in another point of view, double click on it and you can make transpose facility. Can you see? You can check as well as this type of a graph. It is your choice. Okay, it will be saved. Okay, now I'm talking about the bar. Now I'm going to make again a bar. Till now we discussed about the simple bar, cluster bar, and error bar. What about repeated measurement? Because I told you it depends upon the data. It depends upon the data, right? So this data is looking not suitable for making my this type of a bar repeated measure, right? In that case, I need different type of a data, different type of a case study. So what I have to do, I have to go for another data, right? So I already made the data graphics SPSS. Okay, I think I will have some data. Okay, weight loss data, right? I'm going to open it again in front of you, weight loss. Before going in, when it is uploading, we have to understand what is that case study. Do you know right now obesity is a very big problem for everyone? Okay, so what we have to do? We have to do a lot of tasks. We have to walk, we have to make a yoga, we have to make a diet control. Three practices we can do for weight loss. Please try to think. So in this case study, one university or maybe someone has used some 20 obesity suffered guys, right? And they implemented three techniques: walking, yoga, and diet control. And I wanted to check basically which method or practice is good for the obesity sufferer, right? The patients basically. Okay, walking is good for the, or yoga is good for, or maybe the diet is good. Obviously three can be good, but which is the most suitable, right? So basically the test was conducted on 3 months. First month it was done, checked what is the result. Okay, and after they did again three practices, again second month it should be checked. After second month, third month it should be checked. We will see what is the starting and what is the last result. Okay, so data should be accordingly that. Is it clear? So that is then I will go for it. Have a look. I think it is open. So see, what is the baseline? Baseline mean to say when when we started our study. So what was the actual weight for that patient? Can you see this patient? This record patient is I think 105. 105 mean to say more than 100 kilogram. Just think, first month if he applied the technique, the what you say, the weight is reduced 98, and second month again it is 92, and third month it is 75, right? So in that case, I didn't mention that there is no column that like a in first month uh, they applied one technique. I think they applied three techniques together. Okay, so after applying the three techniques together, uh, they check the result. It is reduced, and after second month, it is again reduced. In the last 3 months, 75% or 75, not a 75 kg, right? So it means to say these study is working, that it is good. Okay, so please check all the records. You can take the last one. Can you see? 98, starting patient has a weight 98, then it is reducing 90 and 77. See, third month it has a huge type of a changes. So practically it will be decreasing. Okay, so we need to do for the repeated measurement. Now, can we make a graph? Yes, we can make a graph. Okay, okay, let's see how we can make a graph. go for the graph chart builder and try to reset. Yes, it is already reset. So what I can do now, okay, so we have to use, remember, we have to consider not a, can you see here what type of data I have here? What type of data I have? Please let me know. All data is which type? Scaled, right? In this example, all data is scaled, mean to say numeric and continuous type of a value, right? So it mean to say the first rule that I can have that type of a scale variable, right? I can take all the scale variable at the x-axis, right? Let's see the x-axis. Okay, so I want to have a again bar. You can choose simple bar again and with the arrow and put here at a x-axis. Sorry, I think we have to use a cluster bar. Let's see what it will do for me. First, I think I should reset. Yes, I think it should take a cluster bar now. Let's see. No, 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 it's not good. Let's see what I can do. Simple bar, yes, simple bar we need it, not a sorry cluster bar. Simple bar we need. I use a simple bar. Okay, here. What I did here, so I put a baseline weight after 1 month, weight after 2 months, weight after, okay. So yes, it is okay. I was basically putting all together. Okay, and just a moment. Not, it is not good. Let's see. I think here. Yes, yeah, great. I think it is okay. Yes, it is okay. Please have a look. So what I have to do, actually, I was considering the another type of a data, but it is not actually. We have to consider all that scale variable on the y-axis here. Remember, right? So in this example, I put over the y-axis. Automatically, it will create a indexing. Indexing mean to say like array. It is collection of basically of different type of a value here. Can you see baseline for the starting and weight after 1 month, weight after 2 month, and weight after 3 month, right? So same you can consider here, right? So baseline like that. So in that case, you can create a bar easily. Okay. So okay, so it will create a graph for you. Okay, so this is the example. And what should be the output here? Here. Can you see this is the output here? It can be like here. So see, what was the starting weight around? This is the mean basically. What is the average mean of the patient when we started our practices or when we put in the simulation in the first month? So it was 103 average weight. We're talking about average weight. So and after 1 month, perfectly it is reduced, and after second month it is again reduced, right? And what is the mean average of the last? It is again reduced. So please see what is the conclusion after third month. I can say it is reduced with the 71 mean value of the kilogram. So we can see the diet control is not diet control. It depends. But in this case, only we use diet, walk, and what was the another one? I think diet control and yoga. Maybe yoga. Yeah, right. How many of you know about yoga? Okay, yoga. So they controlled controlled obesity, right? These issues. So this is the repeated bar measure. Next is the pie chart. It is important to know about the pie chart, and I think it is not hidden from you. You know very well the pie chart, how you can create a pie chart. So pie chart can have a like a grade A or grade B. You can easily check for the pie chart. In this example, uh, I want to check uh, if I have given the grade to the students like A or B, and I want to check what is the percentage of the student who scored in the grade, who scored grade A, mean to say who are very intelligent, and who scored uh, grade B. Maybe they are not likely highly intelligent, excellent, but it is they are the grade B. In this graph, can you have the idea? Very less student, I think 2 or 3 students looking like who have grade B, but here 99% they have they obtain the grade A, right? So it means to say you can use. So please you use it. It is your task. You can do the practices later on how to make it. You have to use like here. You can also change. You can also put some variable value over here. You can change the value name here, like data value labels. You can select grade and can put it here. So 54% for grade B and 99% for grade A. You can also do like that. So it is I think it is very easy. You can use easily from uh, the graph chart builder, and you can select. I think pi should be here, right? Can you see this is pi? You can also use. Okay, so it is your task. You can do it. Okay, so I think pie chart is very simple and easy to you. Now, which is important to know about the scattered plot. Yes. So what about the so scattered plot? Scatter plot basically when we will have a two different type of numeric values like a scale variables. In that case, it happens that we should use the scattered plot. Scattered plot will tell me the basically scatteredness. Where is my data is scattered somewhere. Can you see? I have made two graphs. Okay, first one and second one, right? So second one is telling me the scatteredness together, right? And this is telling me about not a scatterness, it is like a relation. So it depends upon two things, right? First and second. So first one is telling me the relation. So please have a look. Marks x-axis is telling me the final marks, and y-axis telling me obtain the final examination again, or maybe the first examination. It should be the first examination. I think I used the wrong one, but here it should be first examination. You can easily check. Okay, so in that case it is showing the marks are just like increasing. If the marks or maybe any variable it can be here, suppose it is a first term marks, it can be increasing, so it is also increasing. Okay, maybe it can be the graph like that, right? It depends. So it can be tell me the actual relation. It is like a positive or negative relation, right? It is going downside, it is going upside. Okay, so this is a basically scattered plot. But if you talk about this one, it is important to understand. I want to show you. Have a look. So this is a first test exam on marks, and this is a final test exam. Okay, see the scatteredness. Can you see the relation that in first exam? Can you see the curve? Curve can be like that. Okay, so it is showing it is going from lower to upward side. Okay, it means to say they have a good performance in exam one. The exam one, the marks are going to be increasing. But here I want to check what is the relation between first test and second test, final test, right? So in that case, please have a look. If student has around a 75% marks over here, okay, so in that time, in that student suppose what marks he or she should have. So they should also a 9 here, right? Okay, like here. So it mean to say it mean that student looks very intelligent. Okay, so sometime the student who has a very less marks here, but in final marks here, can you see here 60 here? Okay, so that student have on that time I think 3. Can you see this one? So now it is that student is passed, but in first exam I think it was he or she was not passed because less than 50%. So please try to understand. This is a scattered plot. Okay, so you can easily create a scattered plot, but how to create? Go for a graph. But for that, I need to open that file here. Okay, I go to that file, graph, chart builder, and so reset on with the scattered here. Can you see scattered plot here? So there are a three. You can also make a 3D. It's your choice. Okay, so but I'm making it very simple now. So you can use suppose first term is here, and what about the second one or the final marks? Okay, it's here. Right, can you see this is the graph will generate, and you can change the color as you want. I discussed with you. And last, you can use the same file, sorry, here. Okay, yes, here can you see what is the chart is telling to me that it is starting from like curve like here, like a arrow. Can you see here? Okay, if I want to make a edit in it, I want to see, maybe I can draw a line. I want to make a relation now. So basically, when we will learn a correlation, so this graph will really help you, and you will understand that yes, this is a graph which can show me the relation. Okay. Okay, so it is slow. Okay, now can you see here? Okay, can you see? Add a reference line. I want to put a reference line. Great. Can you see? Automatically, I can see this is a reference line. It is showing me. I will talk about the reference line later on when we will discuss about the correlation. But here, see, start from 40 and end up to around 80 example, or maybe maximum marks is here 75. So it is the reference line. But here, please see the student start value from 40. Okay, in the final examination, and end marks will be here around 75 somewhere, I think. Okay, similarly in the first exam you can check the student who has, I think one student is the outlier, right? It was, or she, or he, I think she was zero score. So please see, in that case you can have idea that which student is intelligent in the final, and what was his or her status in the first exam. You can compare basically. Okay, you can also see the relation. So it is on the right side. So it is showing me that first exam, the students marks are okay, but in final exam marks are very good. They have a grade, and in between two, I can see if first marks exam marks are increasing, similarly the final marks are also increasing. This is a positive correlation. Last one is here. Okay, I think last. So here, can you see I used three scale variable together again in this example. Please use again three scale variable. You can use three scale variables on the y-axis here. Okay, and one scale variables on the x-axis. It can be also possible. I want to compare the baseline weight. It is your choice, you can use it. So you can also give it some colors as you want. Can you see here, I already made it. So please have a look. The baseline weight are here, right? And weight, this is for not for the marks, it is for the another case study, I think here, right? So you can use this for making a graph. This case study you can consider. Okay, so for that, I want to check, I want to compare, I want to see the graph. What was the initial weight of the patient on the this bar, and what is the progress in 3 months? So it can help me. So basically, please have a look. There is no type of a positive type of correlation. There is like scattered data here. It is the no not a basically, but here I can see if I want to analyze it, so I can easily see. So take example of this guy, only this guy, right? So can you see what was the initial weight of that patient? 120. Okay, and after 1 month, after 1 month, what was the weight? I think it is decreased here. From 120, it was around 105 around. It is decreased. Can you see? And after 3 months, what was the result? Again, see, it was around 97. So see, it is the first weight, it is the second weight, and third weight. Similarly, you can analyze it, but basically it is not giving me the actual relationship here. It is like a scattered. Okay, it is not like the curve like here and here. Okay, so we will talk, when I will talk about the correlation, then I will use the different type of a study, different type of a case study for giving you the good example. But here I have just made a simple plots. Up to now we discuss the graphs, basics, histogram, box plot, error bar, one variable, two variable, three variable, you can make it, bar chart, repeated measure we use, cluster plot. I think I should also discuss the cluster plots. We made it, right? So here, okay, so we discuss all the things. In the end, I would say thank you very much.